Hi all, it is I, Alfred here to assist you in solving, because Alfred, that's what I apparently do, just assist in solving. We're going to be going over the questions that you guys have for your next test, so let's get you guys ready. So, here's the first question that y'all are going to have. What is the value of log base 3 of 3? And we know that when we see this sort of situation, we know that when the base matches the argument, it's the exponent. So the exponent here is 1. In other words, this is log base 3 to the 1. Because these two match, it's just the exponent. So it's just 1. Easy enough. Let's go to question 2. All right. What is the value of log 1? Okay, well, we know log 1 is the same thing as saying log base 10 of 1. So if there's no base given, then we know automatically the base is 10. We also know that 1 is the same thing as anything to the 0 power. So we're going to say 10 to the 0 because I want to match these up. And if these match up again, it's just the exponent, so it's just 0. You also can argue with all of these, by the way. If you don't like the way that I'm approaching it, you can always say it's equal to x. You can always claw it and say 10 to the x is 1, and then 1 is the same thing as, yep, that's right, 10 to the 0. So it's kind of interesting, and then because the bases are equal, then the exponents have to be equal, so x equals 0. You can see again that when I think in this way, I'm still asking the same question, which is how can I write 1 with a base 10? Because if I can match these up, then it's just the exponent. So 2 different ways of doing the same thing. Okay? Cool beans. And you can do it whichever way makes you happy. Okay? Doesn't matter. It's what works. It's how your brain works. It's what works for you. All right. So the next one, log base 243 equals 1 over 9. Okay. So I'm going to go ahead and this one say it's equal to x. We'll go ahead and claw it. So 243 to the x equals 1 over 9. In your mind, you want to think to yourself, how can I get these to be the same base? Well, I know 243 is 3 to the 5th. I know 1 over 9 is 3 to the negative 2. And so I can say 3 to the 5x, when you raise something to another power, you multiply, equals 3 to the negative 2. And because the bases are the same, the exponents are the same. So 5x equals negative 2, and x is negative 2 over 5. And there's my answer. So there we have it. Okay. By the way, with all of these, you can always take the answer and you can substitute it back in to see if it's true. All right, next one. So here, again, we're just going to claw. So we're going to get x squared equals 100. So what times what is 100? Or what's the square root of 100? X is going to be 10. Cool beans. All right, we're zipping through, just nice. Next one. write the log of an exponential you do not need to solve. Okay, so ln x. So the big thing here is, the reason why I'm giving you this is I want you to be able to know that ln x is log base e to the x equals 1/2. And so again, plot e to the 1/2 equals x. It says write as an exponential. So that's as far as I need to go. And next one. So we have log base 2 for x plus log base 2 equals 4. So the rule is that when you add, you multiply. So this is the same thing as saying log base 2 4x times 2 equals 4. And yep, that's right. Plot 2 to the 4th equals 4x times 2, or 2 to the 4th equals 8x, or divide through by 8. 2 to the 4th over 8 is equal to x. And I'm going to do this old school style, and I'm going to say 2 to the 4th, 8 is 2 to the 3rd. So the bases match, so you can subtract the exponents, and you'll get 2 equals x. Okay, if you're like, you don't like these shenanigans, 2 to the 4th is 16. 16 divided by 8 is 2 as well. That works. That's fine. I just wanted to show you a different way of thinking. Okay, next up, just zip it on through. So when you subtract, you divide. So log base, oops, this is 5. This is going to be 3x squared minus 3 over x plus 5 equals 1. And so this becomes 5 to the 1 equals 3x squared minus 3 over x plus 5. Remember, anytime you have fractions and you're not certain what to do, get rid of the denominator. It's usually a good idea. So I'm going to multiply through by x plus 5. And we're going to get 5x plus 25 equals 3x squared minus 3. And then here, what you should always be aware of when you have 3 different terms, you always want to try to isolate. You always want to get everything on one side. So we're going to subtract 5x, and we'll subtract 25. And so 0 equals 3x squared minus 5x minus 28. And then I'm going to try to factor this. Let's go with 3x and x, and 7 and 4. And I can tell you that I'm going to choose 7 and 4 because I know I'm going to get 12 here and 7 here, and 12 minus 7 is 5. And if I do it the other way, I'm going to get 21 and then 4, and that's going to be way too big. So that's my thought process there. And I want a negative here and a positive here. So this is going to give me 3x plus 7 equals 0, and x minus 4 equals 0. So x is negative 7/3, or x is 4. Now, very important, you cannot have a negative inside the argument of the original. So the question is, if I plug in negative 7 over 3, if I plug in negative 7 over 3 here, I'm okay because I'm going to, well, let's find out. Maybe I'm not going to be okay. So we got 3 times negative, what is it, 7 over 3. This is going to be 3. This is going to give me something positive, which is this. And then, so it's going to be 14 over 3, which is going to give me a positive. So 14 over 3, 12 over 3 is 4, right? So this is going to give me a positive answer, so I'm okay. Negative 7 over 3 is 2 and some change. So if I just do 5 minus 2 and some change, I'm okay there. So both of these are okay, so the negative here is okay. You still always want to check. Now let's check out the 4. If I have 4 squared is 16 times 3, we're okay. So both of these values are valid, and they're okay. But you have to check always at the end to make sure you're okay. That's how they try to trick you. Okay. Well, let's do the next one. Okay, so here it's almost like a regular equation. You're just trying to get, instead of trying to get x by itself, you're trying to get the natural log by itself. So if I subtract 5, I'm here, then I'm going to divide through by 5, and we're going to get the natural log of 5x minus 8 equals 5. And from here, what I'm going to do is remember that this is the same thing as log base e. 5x minus 8 equals 5. I'm going to claw it. You get e to the 5th equals 5x minus 8. And solve. So we're going to add 8 to both sides. And then divide through by 5. And there's my answer. So hopefully that's okay. On to the next one. Now we're going to condense. So we're essentially doing what we just did in reverse. So the g could go up here. So this is log c raised to the g. The r can go up here, minus log d to the r. And when we subtract, we divide. So this is log c to the g over d to the r. And that's it. All right, next one. So how do we go about doing this? Well, let's start off by just clawing it. So we get x squared equals 5x minus 6. And again, when you have 3 different terms, right, you're going to move everything to one side. Doesn't really matter what side, but it's usually best to keep x squared positive because you'll create a trinomial, and then you just solve the trinomial. So this becomes x minus 3, x minus 2. So x is 3, and x is 2. And the biggest thing here, you can't just say that this is the correct answer. You always got to check to make sure you're okay here. And you can't assume that just because these are positive, you're okay, right? Here that is the case because 5x minus 6, if you plug in 5 and 3, you still get a positive, but that may not be the case. If x was 1, you would have gotten a negative. So you have to check, right? It's not sufficient to say that these are positive and you're good to go. So, cool beans. All right, let's see, what's the next one? All right. Write the expression below as a single log in simplest form. So I'm going to go ahead and start this one off by putting the 2 up here. So I have log base b 2 squared minus log base b to the 4th. And so, sorry, someone was trying to contact me early in the morning. Wonder who that could be. And so we solve this. This actually becomes 0, right? Because this is 4 squared. This is 2 squared is 4. And so you would get, this whole thing is equal to 0. But I'm going to go ahead and do this. I'm going to write this as 4 over 4, which is log base b of 1, which is also going to be 0 because, right, this is the same thing as saying log base b 4 to the 0. I'm sorry, I want to write 4. I don't want to write 4. I want to write b to the 0. And so this would be 1. So, yeah, you can go all the way through down to 1. I'm sorry, I said 1, 0. Wow. Okay, so 1 is b to the 0, and then because the b's here match up, this is equal to 0. All right, what's going on with me? Let's look at the next one. Expand the log fully. The final answer should be in terms of log x and log y. All right, so we know that when you multiply, you add. So we can rewrite this as such. And then we can take this 4, we can put it in front. We can take this 3, we can put it in front. So 4 log base x plus 3 log base y. And that is pretty much it. All right, so more of the same. When we divide, we subtract. So we can rewrite this as such. Okay. Now, this, I keep going to the same colors. This right here is the same thing as y to the 4/3. So we can rewrite this as log base x minus log y to the 4/3 minus log z squared. And we want to take the 4/3 and we're going to put them in front, and we're going to take the 2 and we're going to put it in front. So this gives me log base x minus 4/3 log y minus 2 log z. And that is it. I'm just rereading the question. All right, express the final answer in terms of logs. Yep, we got it. All right, next up, we got this. So again, the goal is to get these to have the same base. They're both be written as 3, so this is 3 to the 5th times 2x plus 4 equals 3 to the 4th times x plus 2, because when you raise, you get, so this is really, I'm skipping a step here. This is really this. And just the key is to realize that when you raise something to another power, you multiply, and these are quantities. Those are the two things you want to make sure you're clear on. Once you got that down, we can rewrite this as 3 to the 10x plus 20 equals 3 to the 4x plus 8. And then because the bases match, we can say the exponents match. 10x plus 20 equals 4x plus 8. And so we're going to subtract 4x. I could divide through by 2, by the way, to make the number smaller if I wanted to. But we're going to do it this way. 6x plus 20 equals 8. Subtract 20. And we're going to get negative 12 equals 6x. So x is negative 2. And so, yep, we are good. Oh, one more thing I guess I should add. You can always just, if you wanted to, I'm not going to do this for the sake of time, but you can always plug in -2 for here and here and see if it works. Okay, next one. So find the numerical value of the log expression here given. Okay, so again, I'm going to rewrite this as log c squared minus log a to the 9th minus log b to the 9th. In other words, I'm writing these both as negative, and they both have to be negative because we're dividing, right? And so we can take the exponent and we can put it in front of all these, so this becomes 2 log c minus 9 log a minus 9 log b. And you may be asking yourself, Alfred, why can I do this? And the reason why is because in the beginning, they tell us log a is 7, log b is -12, and log c is -6. So now I just replace them. So now I can say 2, that's an a, 2 log a is 7. Wait, no, I can't read my own handwriting. This is log c, my bad. So log c is -6. Log a is 7, and log b is -12. And so I'm left with -12 minus 63 minus, what is that, 108, plus 108. And we can solve that, which is going to give me what? This is going to be, put these two together, this is going to be -2 and 3 is 5, 6 and 1 is 7. And so 108. Let's move Alfred over. 108 minus 75 gives me 33. And there's my answer. Okay. Who is the next contestant? Oh, this is a great question. So the next one, what do we do here? This is a great question because what the heck is 78 125? What is that going to be raised to? So let's do this. I'm going to take me. Let's put me here. And I know that 125 is 5 cubed, so 78 125 is 5 to the something. So let's type that in, 78 125. This calculator does not like me. Okay, and delete. Okay, 78 125. That was way too hard to type in. I'm just gonna divide by 5. So that's 1. That's 2. That's 3. It's like I'm against myself today. That's 4. And 3 more. 125, right? It's 5 cubed. So we said we did once, twice, 3 times, and then you have 3 more. So that's 6. 5 to the 6. Ooh, no, I guess 5 to the 7th is what I said meant. I really am against myself today. Yeah. So it's 5 to the 7th. So we have 5 to the -7, 4x plus 1. And this is 125 negative, well, I guess I should say 5 cubed. So -2x minus 14 Okay, so we know when we raise to another power, we're going to multiply. So I'm just going to jump to 3 times negative 2x minus 14 equals negative 7, 4x plus 1. All right, let's clean it up. So this is going to be negative 6x minus 42 equals negative 28x minus 7. I'm going to add the 28. And then I'm adding 28x because I want to keep it positive. So this is going to be 22x minus 42 equals negative 7. Add 42 to both sides. By the way, 42 is 6 times 7. So if you have 6 times 7, you lose 1 7. That's the same thing as 5 times 7, which is 35. Or 42 minus 7 is 35. And x is 35 over 22. This is 5 times 7. This is 2 times 11. So there's nothing that cancels out. And it's not pretty, but it's good enough. Okay, cool. Next up. So what do we do here? More of the same. So this is 5 to the negative 3 raised to the 2x minus 28. The other side is 5 to the 2x squared minus 8x. So we can say that negative 3 times 2x minus 28 equals 2x squared minus 8x. Now I'm going to definitely do this, and this is okay. Because these both are divisible by 2, I can factor a 2, or I can divide through by 2. So if this is, you're not visualizing this, you could factor out a 2 and then divide it by 2. And so this would be leaving with negative 3x minus 16. 2 divided by 2 is 1. 8 divided by 2 is 6. And on the other side, we're going to get x squared minus 4x. And the reason why I'm doing that, is I want to try to keep the numbers as small as possible because I don't want to pull out a calculator. So I'm here, and then I'm going to add 3x. So 48 equals x squared minus x, and then I'm going to subtract 48. So again, the point is, what I want to do is I want to get always my trinomial by itself, right? That's the name of the game. Now, if I did this right, this is going to be interesting because that's not going to be anything pretty. Because 48 is 8 times 6. So, okay, let me just double check. Minus 2, that's 16. That's 4. What I'm doing right now is I'm making sure that I didn't make a mistake, because this next step is a little painful. So what do? It's not the end of the world. You just have to quadratic formula it. So negative b plus or minus square root b squared minus 4ac all over 2a. So this becomes negative 1 plus or minus negative 1 squared minus 4 times 1 times negative 48 all over 2 times 1. And this gives me, I have to keep having to move my head around, 1 plus or minus 1 plus, 48 times 4, 16 and 3, 192. Sorry, 16 and 3, yep. Over 2. So 1 plus or minus square root 193 over 2. And yep, and that's it. You can't break that down. It's as good as it's going to get. Can we? No. Okay. So wonderful. By wonderful, I mean very ugly. But that's okay. If you don't know, plug in the quadratic formula. You actually can just plug in the quadratic formula if you want to. Okay. Next one. Alfred needs coffee. Okay. All right. So we've seen these situations before. I'm giving you X and Y points. You're just going to substitute them in. So this is like a review of old stuff. So we can go like so. This tells me that A is 7. So now when I write Y equals AB to the X, I can say Y equals 7B to the X. And the second pair of points, you just plug them back in. So you got 875 equals 7B to the third. And then we're just going to divide by 7. So where's that calculator? 875 divided by 7. It's 125. And we've seen this so frequently, we know that B is 5. 5 cubed is 125. If you needed to, you could also, let me go. Uh-oh. All right, this is Alfred once more. Apologize, guys. We were finishing up this problem, and Mr. Wayne lost a lot of money during COVID, and yeah, so we don't have the best tech anymore. Anyways, but we can still work this out. So what I was going to say is, if you're here, you could take the cubed root, and this would still tell you B is 5. All right. Let's keep going. All right, so next question. So an element with a mass of 600 grams decays by 27.8% per minute to the nearest tenth of a minute. How long will it take until there's 2 grams? Okay, so what you need to realize is you are using this formula here to solve this. Okay. I should be plus or minus. So you're going to start with 600. That's your principal. You're going to lose 27.8%. So I'm going to write it this way because percents are out of 100. And I want to emphasize that. And saying to the nearest tenth of a minute, so this is your t, it's going to equal to, what do you want? 2. So this is what we're solving. So I'm going to do 2 steps in 1. I'm going to divide by 600, which is just going to give me 1 over 300. And then we're going to subtract that, which is just going to be 1 minus 0.278, which is 0.722. Here's t. And this is where it gets interesting. Anytime you have an exponent as the variable, you want to get rid of this. So we can do this in multiple ways. You can claud if you want to and get log 0.7. And I wrote that too big. Log 0.722. 1 over 300 is t. Or if you prefer, you can just take the log of both sides. So you could have, let me rewrite this over here. And I could have just taken the log of 0.722. Because if this and this match up, it's just t, and t equals log 0.722, 1 over 300. Either way, you're good to go. From here, you would just type this into the calculator and see what you end up getting. So let's do that. I keep moving me. So what does this get me? So you can actually just go, if you hit math and do log base, we can type it in directly. You could also do the change of base, right? You could rewrite this as log 1 over 300 over log 0.722, and that would give you the same answer. So if your calculator doesn't have that function, you can do that, but I'm just going to do it directly. 0.722. This is 1 over 300. Okay. So I guess I got to do it the other way. Log 1. And by the way, this is an error on this calculator because I was under the impression that there shouldn't be any issues here, but with this calculator, but this thing is not the greatest thing in the world. I think it's better looking than it actually works, I guess is what I should say, but it's okay. So I'm getting 17.5. So this is, I guess, what funny that this shows up, right? Okay. So 17.5, and that's it. So there we go. Wants to do the nearest tenth of a minute. That is a tenth of a minute. We're good.